Right, so we are learning something interesting today. How are you all?
Yeah, great. What about you?
Yeah, I'm very strong. And what we are going to learn is something that it's very common. It's all around us. Always know that math is just things that we do in every day that they have decided to put in textbooks. And sometimes when those same things are put in our books, we get very confused about them. So what we are going to learn today, it's called algebra. Say algebra.
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 All right. So this shouldn't sound scary to you. Like I said earlier on, everything you learn at this level are things that you might have been learning years before now. Just that at some point in time, you get to know their names. So algebra is from an Arabic word. However, this concept has been all around us. It's from an Arabic word called al-jarb. Say al-jarb.
Algebra.
Al-jarb.
Algebra.
This means the connection of broken parts, or fixing broken parts. Before the word became mathematical, it was used in everyday world, in the ancient world, to represent fixing things, like fixing bones. So it was words that were used. So let's say we want to fix something, we want to look for something that is missing. So the word aljab means reunion of parts. So reunion of broken parts. Broken parts. And this shouldn't be so complex to your minds. For example, if I have these two pens, watch here. If I have this pen, and then you've seen me hold this before. So watch. And then I remove here, right? I've broken it. Is that okay? And then I ask you, what is the missing thing here? What's the missing thing? And I'll show you this. After watching what I had earlier on, and I show you this now, what is missing?
The cover.
The cover, right? So I can, when I put this cover back, I've done a reunion, basically. So there are various things in our world like that. There are days you want to eat, and then you have bread, and then you add what? Margarine to it. So you have made a reunion, or you have connected the bread to the what? To the margarine, or you have connected margarine to bread. So there's that bread. So there's that connection between the two. Is that okay? Now, how does this apply in our everyday world? I've told you that before we get into what happens every day, we've seen this even as early as KG, where you see something like this: 2 plus box is equal to 5. Who has met this before? Almost every one of us, right? So 2 plus box is equal to 5. What's missing? What do we put here? 3. Good. So this idea of joining, so it looks like something here, we've broken this part, and then you are using this. This is going to help you predict what is supposed to be here. So let me bring the pen again. Watch here. So I have this pen as my final product, my final answer. Then I have this. Then you are supposed to look at this to fix this part. So when I just put this one here, what do you think I must put at this side? The cover. So I can say that the pen plus this one. So let me put a plus here and operation there too. So this, when I add this 1, 2, I'll get this one back. Is that okay? So it's something we've been doing all our years. So algebra means reunion of broken parts. However, so it's something that we do every day. There was one man who decided to use this concept and brought it into math. This everyday idea of fixing things, and he brought it into math. His name is Al-Khwarizmi. Say Al-Khwarizmi.
Al-Khwarizmi.
Yes, Al-Khwarizmi. So his name is Al-Khwarizmi. Al-Khwarizmi. He was an Arabian mathematician, and he decided to make this thing into maths. And it was like a very big breakthrough where people could be able to use this thing to predict missing things. For example, let's try this. I'm thinking of a number right now. You don't know, right? Okay, but that number, so that number is unknown to all of you, but you can be able to predict. Okay, I'm thinking of a number. When I add 2 to that number, I get 5. What number am I thinking about? 3. So simple. Okay, I'm thinking of another number again. When I add, okay, I'm thinking of another number again. When I subtract 4 from that number, I get 1. What number was I thinking about? 5. So that's the idea. You're able to predict missing things. So let's say before Al-Khwarizmi make algebra very popular, people could tell that, okay, I have 3 goats. Then a certain number got missing. I don't know the number, but I realized that at the end of the day, I have only 1 goat in the what? The pen, right? How many goats were missing? So I have 3 goats, right, in the pen. I wake up the next morning and then I realize that there is only 1 goat there. How many goats were missing? 2. So you're able to just use your normal so people were doing this way before Al-Khwarizmi decided to make this concept mathematical to be studied. Is that okay? All right, so let's do something. So the whole idea of algebra is the ability to be able to predict the unknown. So let's try something. So everybody pick a number. Pick a number. Are you ready? Any number at all. Any number at all. So let's see if we can be able to predict the unknown. Any number at all. Are you ready? Have you picked a number?
No.
Okay. Multiply the number by 2. Multiply the number by 2. Have you done that?
Yes.
Okay, so add 10. Add 10. Add 10. Have you done that?
Yes.
So now divide by 2. Have you done that? Divide by 2. Have you done that? Divide by 2. Now subtract the number you started with from this your current answer. So as when I chose 5, I'll subtract 5 from this answer after I've divided by 2. What do you get? Oh, you're still calculating?
I'm done.
Okay. What did you get? 5. What did you get? What did you get? So it looks like everybody, what did you get? 5. It looks like everybody got 5. Is that not interesting?
Yes.
Is that interesting? Yes. All right, so good. All right, so it's okay. Now, how was I able to get the answer for everyone? We could represent. So let's try something. Usually in maths, when you don't know something, when you don't know any number, you have to represent that number with an alphabet. You could represent with A, B, C, D, E, F, any alphabet at all, or even Greek alphabet like alpha, beta, gamma, and the rest. So, but then amongst all of them, I hope everybody has seen a math book with some things X, Y, Z. Who has seen those things before? Almost everyone. So 1, X, Y, you see them, very complex stuff. But it looks like one of them has become very popular. Which of them is that?
X.
X has become so popular. So we'll use him today as well. Now, anything I don't know, I represent it with an X. So I don't know what any one of you chose. Any one of you picked. I don't know what number was in your head. So I represent with what? X, right?
Yeah.
Okay, so now let's multiply. Let me use here. I'll be doing some other things. So, alright, so I'm using X. So I don't know the number in your mind. Anything I don't know, I use what? I use X, right? Then I told you to multiply that number by 2. Is that okay? So that would be 2 times what? X. But in algebra, whenever you are multiplying something, you can decide to leave the multiplication sign out. So instead of writing 2 times x, I can write what?
2x.
I can write 2x. Good. I can write 2x. Then I said, what's the next instruction I gave? Add what? Add 10. So I would have 2x plus 10. Is that okay? Yep. Then I also said that what? Divide by 2. So the first step, that will be 2x plus 10. Divide by 2. So I'll divide this by 2. Divide this also by 2. Now 2 divided by 2 is what? 1. So I would have x. What's 10 divided by 2?
5.
I hope you all know that we could write division problems as fractions.
Yes.
Alright, so I would have x plus 5. Then I said that what? Subtract the number you chose. So that will be what? X. Right? So subtract x. So that would be x plus 5 minus x. Right?
Yes.
Subtract means remove x. So I could subtract x. What will I get as my final answer? 5. So therefore, it doesn't matter what number I chose. Joe, pay attention. It doesn't matter what number I pick. Even if I pick 50, 500, whatever number I pick, I'll still arrive at the 5. Do you want us to try that?
Yes.
Let's try. Alright, let's try it out. Good, good. Okay, let's try. What number would you want to try on? 1,000. Okay, let's try. So if I pick 1,000, 2 times 1,000 will be what? 1,000. Alright, good. That will be 2 times 1,000 be 2,000. Right?
Yes.
Then I said add 10. So that will be 2010. That's like somebody's birthday. Birth year. Oh, it looks like somebody. And then I said what? Divide by
2.
Divide by 2. So what's 2010 divided by 2?
1,010.
No, a little 1,000.
5.
Good. 1,000 and then 5. Is that okay? Then I said what? Subtract the number you picked, right? So that would be 1,005 minus what? 1,000. What do I get? 5. So now let's try some other number. Pick any number at all.
200,000.
Oh, let's use smaller ones. You could even pick a fraction. 15. Good. Okay, let's try 15. So if your unknown number is 15, so twice of the 15 will be what? Plus 10 will be what?
40.
Plus divided by 2, that will be 20. And then subtract 15. Okay. 20 minus 15 is what? 5. Perfect. Let's try some other number again. I think so. 5. 2 over 5. Okay. Let's try fraction. Okay, 2 over 5. Let's try. So let's say 2 over 5, right? Then we said what? Multiply by 2. So 2 over 5 times 2. That would be 4 over 5. So times 2, okay, 4 over 5. Then we said what? Add 10. So 4 over 5 plus 10. Addition of fractions, they must be like fractions. So that would be, this becomes 5. That would be 4 over 5 plus 50 over 5. Do you agree to that?
Yes.
Alright, so that would be 54 over 5. So we said what? Where are we now? Add 10, right? 54 over 5 divided by 2. Okay, divided by 2. That will be times, divided by 2 is the same as 54 over 5 times 1 over 2. That will be 54 all over 10. So where are we? Divided by 2. So 54 all over 10, right? Yes. Then we said subtract what you began with. What did we start with? 2 over 5. So 54 over 10 minus 2 over 5. That will be times 2 times 2, right? Yeah. We would have 54 all over 10 minus 4 over 10, right? Yeah. What's 54 minus 4? 54 minus 4? 50. 50 over 10. What's 50 over 10? 50 over 10? 5. 50 divided by 10? It's 5. So it works for fractions as well. Do you get that? So no matter your unknown value, we could still 2.5. Okay, you got. So go and try that at home. Let's try and see if it works for decimals.